बीती एजुकेशन करके दिखाएंगे।
Hello student, today we shall study ratio, proportion and partnerships. It is a very interesting lecture because it is a concept heavy lecture, and once these concepts are mastered, you will use these throughout the rest of your aptitude preparation. So let's get started with ratio, proportion and partnerships. Ratio, proportion and partnerships. Let me start by giving you the basic definition of ratio. Ratio. The comparison between two quantities of the same kind of units is the ratio of one quantity to another. As you can see on the screen, ratio is equal to A is to B, which can also be written as A by B. Now here in the red you can see that the important thing is that A and B must be of the same units. We cannot compare things of dissimilar units. So mangoes can only have a ratio with mangoes, that is number of mangoes. Number of apples can only have a ratio with number of apples, and so on and so forth. In the ratio A is to B, as you can see on the screen, A is the antecedent and B the consequent. I hope this is very clear. Let's move on. Now there are two situations. In the ratio A is to B, which is equal to A upon B, B cannot be 0. And similarly, if A is equal to B, then the ratio becomes 1. I hope this is very clear. Let us take up 3 examples to find the values of certain ratios. Example 1. Find the ratio of 4 to 6. Example 2. Find the ratio of 2 by 3 to 4 by 5. And example 3, find the ratio of 5x to 3y by 4. Let us solve these examples one by one. For example 1, as we can see in the solution, 4 is to 6 is equal to 4 by 6, which can be further simplified as 2 by 3, which is 2 is to 3. I hope the first example is clear. Now the second example. 2 by 3 is to 4 by 5 is the same as 2 by 3 divided by 4 by 5, which is the same as 2 into 5 upon 3 by 4, because 5 will go up, 3 will go down, which is equal to 5 by 6, which is the same as 5 is to 6. So for example 2, the answer was 5 is to 6. Now let us see example 3. 5x is to 3y by 4 is the same as 5x divided by 3y by 4. So 4 will come up and you will have 5x into 4 divided by 3y, which is the same as 20x upon 3y, which is 20x is to 3y. Thus, we have solved all the 3 examples. Let me mark in red color the answers of the 3. For example 1, we solved it and got as 2 is to 3, our answer. In example 2, our answer was 5 is to 6. And in example 3, our answer was 20x is to 3y. These are the simplest expressions that these answers can be reduced to. Let us move on. Now let us study what are commensurable ratios and what are incommensurable ratios. Definitions. First of all, commensurable ratio. As you can see on the screen, a commensurable ratio is the ratio of two quantities which can be expressed by the ratio of two integers. Example, 5x is to 17x is the same as 5x upon 17x, which is the same as 5 is to 17. Thus, 5 is to 17 is a commensurable ratio because both numerator and denominator, or antecedent and consequent, are integers. Incommensurable ratios are those which do not follow this rule. So let us see their definition. Incommensurable ratio is the ratio of any two quantities in which one or both are a surd quantity. And as we know, a surd cannot be reduced to a perfect integer expression, thus making it an incommensurable ratio. As an example, suppose I ask you to find the ratio of the length of the side of a square to the length of the diagonal of the same square. What kind of a ratio will be generated? Let us draw the diagram and see for ourselves. On the screen, you can see in this square, x is the side. So we know that the diagonal will be x root 2 by Pythagoras theorem. We are asked to find side upon diagonal is equal to x upon x root 2, which is equal to 1 by root 2 because x gets cancelled out, which is equal to 1 is to root 2. Now we know very well that root 2 cannot be further simplified in an integral fashion. Thus, 1 is to 2 is an incommensurable ratio. I hope this example made it very clear for you to understand both commensurable and incommensurable ratios. What is the definition of a compounded ratio? When two or more than two ratios are multiplied term-wise, then the final result is called a compounded ratio of the given ratios. Let us take two examples to understand compounded ratios. Compounded ratio, the first example. What is the compounded ratio for 2 is to 3 and 4 is to 5? And the second, what is the compounded ratio for 3x is to 4y, x is to y, and x is to z? Let us solve both these examples one by one. So the solution to the first example, compounded ratio would be 2 is to 3 into 4 is to 5. So 2 into 4 is to 3 into 5, which is nothing but 8 is to 15. That is the answer to the first example. The second example, the solution. Let us do it stepwise, as you can see on the screen. 3x is to 4y, into x is to y, into x is to z. So multiply all the antecedents together and multiply all the consequents together. 3x into x is to 4y into z, which is equal to 3x cube is to 4y square z, which is equal to 3x cube divided by 4y square z. Thus, the two answers to our questions have been marked in red. For the second example, the answer was 3x cube is to 4y squared z, and for the first example, the answer was 8 is to 15. I hope that the concept of compounded ratios is now clear to you. So let us move on. Now we will study what are duplicate ratios and triplicate ratios. Very simple. A duplicate ratio is the compounded ratio of two equal ratios, and the triplicate ratio is the compounded ratio of three equal ratios. So let's see on the screen. Duplicate ratio is the compounded ratio of two equal ratios, and triplicate ratio is the compounded ratio of three equal ratios. Let us take an example each of both. For duplicate ratio, example A is to B. So what will be the duplicate ratio for A is to B? A by B multiplied by a by b, which gives you a square is to b square. Thus, a square is to b square is the duplicate ratio of a is to b. An example of triplicate ratio, as you can see on the screen. A is to b is the ratio, and so the triplicate ratio would be a by b into a by b into a by b, which is equal to a cube is to b cube. I hope this is very clear. So now we can take up 3 good examples to illustrate duplicate and triplicate ratios. Here are the examples. Examples 6, 7 and 8. Example 6 reads, find the duplicate ratio of 4 is to 5. Example 7, find the triplicate ratio of 4 is to 5. And example 8, if a is to b is the duplicate ratio of a plus x is to b plus x, show that or prove that x square is equal to ab. Let us solve examples 6, 7 and 8 now. Example 6, solution. 4 by 5 multiplied by 4 by 5 gives us 4 square upon 5 square, which is equal to 16 is to 25. This is our answer, plain and simple. Example 7 will naturally be 4 by 5 into 4 by 5 into 4 by 5, which is 4 cube by 5 cube. Now we know 4 cube is 64 and 5 cube is 125. So the answer is 64 is to 125. Now let us take example 8. Let us solve example 8 stepwise. A by b is the duplicate ratio of a plus x is to b plus x. So as you can see on the screen, the very first step, a by b is equal to a plus x whole square divided by b plus x whole square. Where did this step come from? Because it is the duplicate ratio. So we just multiplied a by x upon b by x with a by x upon b by x. So in the next step, this simplifies to a by b is equal to a square plus 2ax plus x square divided by b square plus 2bx plus x square. Simple formula of a plus x whole square and b plus x whole square. Cross multiply. As you can see with the red marks I have indicated, how we have cross multiplied. The denominator b square plus 2bx plus x square goes up and b goes up to the RHS, and you get a times b square plus 2bx plus x square is equal to b times a square plus 2ax plus x square. 2abx and 2abx get cancelled out from both the sides. So we are left with ab square plus ax square is equal to ba square plus bx square. As I have shown with the red arrows, take ab square to the right hand side and take bx square to the left hand side. Thus, ax square minus bx square will be equal to ba square minus ab square. Take x square common on the left hand side, a minus b, and take ab common on the right hand side, a minus b. So the final answer will be x square is equal to ab. And this is what we were asked to prove, hence proved. I hope these simple examples are making the conceptual clarity better. Let's move on. Now we will study what are subduplicate ratios, subtriplicate ratios, and reciprocal ratios. Let us see the definitions on the screen now. Subduplicate ratio. As we can see in the notepad, for any ratio a is to b, the subduplicate ratio is defined as square root of a is to square root of b. Subtriplicate ratio. As we can see in the notepad, for any ratio a is to b, the subtriplicate ratio will be defined as cube root of a is to cube root of b. And reciprocal ratio, as we can see in the notepad, for any ratio a is to b, the reciprocal ratio will be defined as 1 by a is to 1 by b, which is the same as b is to a. So these are the three important definitions. Let us move on. Let us take two examples, example 9 and example 10, to illustrate subduplicate, subtriplicate and reciprocal ratios. Example 9. Find the subduplicate ratio of 16 is to 25. And example 10. Find the subtriplicate ratio of 512 is to 729. What horrifying numbers these are, but they are very simple to solve. Solution. Example 9. 16 is to 25, the subduplicate ratio will be square root of 16 is to square root of 25, which will be 4 is to 5, as I have marked in red. For example 10, 512 is to 729. The subtriplicate ratio will be cube root of 512 is to cube root of 729. As we know, cube root of 512 will be 8 because 8 into 8 into 8 is 512, and cube root of 729 will be 9 because 9 into 9 into 9 is 729. Thus, examples 9 and 10 have been explained. Let's move on. Equivalent ratios. Now we will study this. Here is the definition of equivalent ratios. As you can see in the notepad, equivalent ratio is obtained by multiplying or dividing both the numerator and the denominator of a ratio by the same quantity. Thus, if the ratio is a by b, 3a by 3b, 10a by 10b, 100a by 100b, minus 5a by minus 5b are all equivalent to each other. Hence, they are called equivalent ratios because anyway the numerator and denominator, the additional thing we have added, will get cancelled out. Minus 5, etc. Here are some examples. Thus, for a is to b, ax upon bx is an equivalent ratio, just like a into 1 by x upon b into 1 by x are also equivalent ratios. So, for a is to b, many equivalent ratios can be 2a by 2b, 3a by 3b, 21a by 21b, and so on and so forth. Let us take up example 11. It says, find two equivalent ratios of 4 is to 5. Let us solve example 11. Here is the solution in the notepad. 4 by 5 is 4 by 5 into 2 by 2, which is 8 by 10. So that's one equivalent ratio. Similarly, if we multiply by 3 by 3, 12 by 15. Thus, 4 by 5, 8 is to 10, 12 is to 15 are all equivalent ratios. Now let us see how can we compare ratios. Comparing ratios. As we can see in the notepad, to compare given ratios, we convert them to fractions and then we can equate the denominators. Example 12. Which is greater, 3 is to 4 or 4 is to 5? Now, as I have marked out in red, 3 is to 4 or 4 is to 5, we can mentally solve this question. We know 3 by 4 is 0.75 and 4 by 5 is 0.8. So obviously 4 is to 5 will be greater than 3 is to 4. But suppose we are not able to solve it mentally like this in a competitive exam, it is always a strength to be able to solve questions mentally. But let us see the rigorous method also. Here is the solution. 3 by 4 and 4 by 5. 4 and 5 have a common LCM, or rather they have an LCM 20. Now the only way we can make the denominator same so that we can then compare the numerators and decide which fraction is greater is by bringing both of them to the LCM level. 4 and 5 have an LCM of 20. That means we need to multiply the first ratio 3 by 4 by 5 by 5 and the second ratio 4 by 5 by 4 by 4. What will be the result? Let us see in the notepad. 3 by 4 multiplied by 5 by 5 gives us 15 by 20 and 4 by 5 multiplied by 4 by 4 gives us 16 by 20. And as we just saw that because these are equivalent ratios, so the value actually has not changed, so we can always take the liberty of multiplying like this. So 3 by 4 actually becomes 15 by 20 and 4 by 5 becomes 16 by 20. Now we can directly see the numerator that 16 is greater than 15 and denominators are the same. Thus, 16 by 20 will be greater than 15 by 20 and hence 4:5 is greater than 3:4. I hope this example made it very clear. So remember, dear student, you can be given more than two ratios to compare. The trick remains the same. Make the denominator same. Let us take up example 13. In the notepad we can see example 13 says, divide rupees 2400 in the ratio 3:5. Now what will be our approach? Before I start writing the solution, what will be our approach? 3:5. 2400 rupees is to be divided in two parts, 3:5. The two parts bear a ratio of 3:5 to each other. Add up the two parts, 3 and 5. That becomes 8. Divide 2400 by 8. So that gives you 300. That means each part out of these 8 parts is worth 300. So 3 parts will be 900 and 5 parts will be 1500. So you can always solve such questions mentally. Let us solve it in the notepad. Solution to example 13. As we just saw, 3 plus 5 is equal to 8. So the first part, which is actually the 3 part, will be 3 divided by 8 of 2400. Now where did this 3 by 8 come from? Because total is 8 and we are asked to find the 3 part out of 8. Hence 3 by 8. 3 by 8 into 2400 gives us 900 rupees. And similarly the second part, which is 5, gives us 5 by 8 into 2400, which is 1500 rupees. In fact, you don't even need to do the second calculation because once you know 900, you can subtract 900 from 2400. Let me in the red ink write down rupees properly. Now rupee has a very nice beautiful symbol. So we have made that nice beautiful symbol of rupees. Here it is. So I hope this example 13 was clear. Let us move on to example 14. A sum of money was divided between Steve and Bill in the ratio 3:7. Steve got $240. How much did Bill get, or what did Bill get? Now look at question 14 before we start solving. There is a sum of money X which got divided in the ratio 3:7 and Steve got $240. That means the one who got the 3 part got $240. Total parts made were 10. So 3 out of 10 was 240. So how much will be 7 out of 10 out of the total X? It's very, very simple. 3 out of 10 of the total X was 240. So from here you can find out X and then the question can be solved. Let us write it down and solve it in the notepad. Solution. Let us say the total amount was X dollars. This implies Steve's share was 3 by 10X, but that was equal to $240 given to us in the question. Thus, X will be equal to 800. So Bill's share now will be 7 by 10 of 800, which is $560. But actually you don't need to do the second multiplication because if you know 240 and if you know 800, subtract 240 from 800 to get 560 and the question can be solved. I hope that is very clear. So we now move on. Example 13 and 14 have been solved, and we move on to some important results in ratios. While studying ratios, there are some commonsensical results that we come across. Let us make a summary of all these results on a page and revise it for our understanding. We will give it the title Important Results. Here they are. First, A by B is equal to Ka by Kb, where K is a constant, because K will get cancelled out. So A by B can always be written as Ka by Kb, where K is any constant, 2 or 3 or -5 or anything. Second result, A by B is equal to A by K upon B by K, because ultimately A by K is the same as A into 1 by K. Thus, the second result is the same as the first result. Third, A by B is not equal to A plus K upon B plus K. Very, very important. Just put in the values and see whenever you have any doubt, and you will realize that A by B cannot be equal to A plus K upon B plus K. Next, A by B is not equal to A square upon B square, where A and B are not equal, because if they were equal, it would be 1 by 1, and so it would be 1 square by 1 square, which would be equal. So the only exception is A should not be equal to B. A is to B is to C is equal to X is to Y is to Z is equivalent to saying that A by X is equal to B by Y is equal to C by Z. A very, very important result. A by B is greater than X by Y if AY is greater than BX. Just cross multiply. B goes to the right side, Y comes to the left side, and you have AY greater than BX. Next, A by B is less than X by Y if AY is less than BX. I hope this is very clear. Next, an important result. If A by B is equal to C by D is equal to E by F is equal to etc. is equal to K, some fixed quantity K, then this implies that the sum of numerators divided by the sum of denominators will be equal to K, which implies A plus C plus E plus upon B plus D plus F plus is equal to K. But we know K is A by B, and by the theory of equivalent fractions, A by B can be MA upon MB, can be NC upon ND, can be minus 5E upon minus 5F, and so K can be MA plus NC minus 5E upon MB plus ND minus 5F, etc. etc. An interesting result indeed. Next, if A by B is greater than 1 and A is greater than B, then A plus X upon B plus X will be less than A by B. How to prove it? And here the assumption is A, B and X all are natural numbers. How to prove it? Whenever you have a doubt in ratios like this, just take some values and prove it. Let us say A by B is 3 by 2. It is greater than 1, 3 by 2, and A was greater than B. Then A plus X upon B plus X will be less than A by B. Let us take X as 1. So you will have A plus X will be 3 plus 1, which is 4, and B plus X will be 2 plus 1, which is 3. Now we know 3 by 2 is 1.5 and 4 by 3 is 1.33. So we found out that 1.5 is greater than 1.33. Hence A by B is greater than A plus X upon B plus X. We have just proven it. Similarly, if A by B is less than 1, that is A is less than B, then A plus X upon B plus X will be greater than A by B. Just reverse, make it 2 by 3 and check, and you will be able to check it. And last but not the least, A square upon B square, A cube upon B cube, root A upon root B, and cube root of A upon cube root of B are respectively called the duplicate, triplicate, subduplicate and subtriplicate ratios of the parent ratio A is to B. I hope this important result summary was clear. Do revise it thoroughly. Let's move on. Example 15. Find the compounded ratio of A plus X is to A minus X, comma, A square plus X square is to A plus X whole square, comma, and a square minus x square whole square is to a fourth minus x fourth. Now this is an interesting example as it will help you understand how these expressions can be simplified. Here is the solution. Let us see the solution. The compounded ratio will be, as we can see in the notepad, a plus x upon a minus x into a square plus x square upon a plus x whole square into a square minus x square whole square upon a fourth minus x fourth. This, when simplified, gives us a plus x upon a minus x into a square plus x square upon a plus x into a plus x into a square minus x square into a square minus x square in the numerator, because whole square, so the bracket gets multiplied twice, and the last denominator a square minus x square into a square plus x square, because we know p square minus q square is p minus q into p plus q, and here p was a fourth, or rather a square, and q was x square. One by one you can see that these expressions get cancelled out. I am cancelling them out one by one now. I hope you are able to see how they are getting cancelled. And by magic, everything got cancelled out. So all that is left is 1. And that is the final answer of this expression. So the question has been solved and the final answer is 1. Wonderful. Let us move on. Let us take up another practical example. As we can read in the notepad, example 16. The ratio of number of boys to number of girls in a school of 1638 is 5:2. If the number of girls is increased by 60, then what must be the decrease in the number of boys to make the new ratio of boys and girls as 4:3? Here is the solution. Total number of students given to us is 1638 and the ratio of boys and girls is 5:2. So the number of girls will be 2 upon 5 plus 2 into 1638. We have seen earlier why 2 upon 5 plus 2, because 2 and 5, 7. So 2 of 7, that is 2 by 7th of the total will be girls. If you solve it, you get 468 girls. And so boys will be 1638 minus 468, which is 1170, which is also given on the notepad as 5 by 7 of 1638, which is 1170. Now, the new number of girls is increased by 60. So it will be 468 plus 60, which will be 528. Now, if you look at 528 girls, if you compare it with the new ratio of boys is to girls, 4:3, 528 corresponds to the denominator, which is 3. That means when the ratio is 4:3, 3 is equal to 528. So what will be 4 equal to? So when 3 corresponds to 528, 4 will correspond to how much? This will give us the final number of boys in school. 4 into 528 divided by 3, which is equal to 704. But originally how many boys were there? 1170. And what is asked in the question? What should be the decrease in the number of boys? And so the answer will be 1170 minus 704, which will be 466. As you can see, 1170 original number of boys, 704 final number of boys, and so the final answer, which is the decrease in the number of boys, will be 1170 minus 704 is equal to 466. That is our final answer. I hope this is absolutely clear to everyone. It is a nice question, and in a competitive exam, you can try and solve it mentally or from the options. Let us move on. Example 17. As you can see in the notepad, a bag contains an equal number of 1 rupee, 50 paise and 25 paise coins respectively. If the total value of all these coins is 35 rupees, then how many coins of each type are there? Read the question once again and understand it. Here is the solution. Let us say that the total number of coins of each type is X. Now, if X is the number of coins of each variety, then we are given that the number of coins of 1 rupee value is X, 50 paise value is also X, and the number of coins of 25 paise value is also X. So, if you add up the value, then 1 into X plus 0.5 into X, 0.5 because 50 paise is 0.5 rupees, we are making the equation in rupees, plus 0.25X should be the total value, but the total value is given to us as 35 rupees. So a very beautiful equation in rupees is prepared. Solve for X. This gives you 1.75X is equal to 35. And so X will be 20. So this answer means that there are 20 coins of 1 rupee, 20 coins of 50 paise and 20 coins of 25 paise. So if you have any doubt, mentally calculate and you will see they will add up to 35. Let's move on. Here is example 18 in the notepad. The sum of squares of three numbers is 532 and the ratio of the first to the second as also of the second to the third is 3:2. What is the second number? Let us solve example 18. It is given to us that the first number is to the second number is equal to 3:2. This is the ratio given to us. But it is also given to us that the second number is to the third number is equal to 3:2. So now the second number was 2 and here the second number was 3. So in order to get a continuous ratio of first is to second is to third, we will need to make this 2 and this 3 common. Now we know how we can do that. Convert it to the LCM. Now to convert it to the LCM, we will multiply the first ratio by 3:3. So this will become 9:6. And we will multiply the second ratio by 2:2. So this will become 6:4. So from here, the first is to second is to third numbers ratio now becomes 9:6:4. I hope this is very clear. So these are the three numbers in this ratio. Now the condition given to us is the sum of squares of the three numbers is 532. So let us say the first number was 9x, the second was 6x, and the third was 4x. Because remember, when the numbers were in this ratio, 9:6:4, so this is just a ratio. We'll have to put some x here. So the numbers will become 9x, 6x, 4x. We put x, y, a, b, c, whatever. But to make the equation, the sum of squares of three numbers. So 9x whole square plus 6x whole square plus 4x whole square is given to us as 532. This is the equation. Now the things are relatively easier because if you add on the left hand side, you will have 81x square plus 36x square plus 16x square is equal to 532. This is nothing but 133x square is equal to 532. So this will give us x square will be 4. This will give us x will be plus minus 2. Remember, it is important to understand that x can be plus or minus 2. Both values seem to be acceptable here. So this means the question was, what is the second number? The question actually was asking us, what is the second number? So the second number we know is 6x. So 6 into plus minus 2. So that means plus minus 12 is our final answer. You can take a look at the entire solution in example 18 once again and understand it carefully. It's a beautiful question. We move on to example 19. Okay, as you can see in the notepad, example 19 says, a Raja has a bag containing 1 rupee, 50 paise, 25 paise and 10 paise coins in the proportion 1:3:5:7. If the total amount is rupees 22.25, then find the number of coins of each kind. We have solved one question of this type earlier. Let us solve this one again. Solution. In the earlier question of this variety, since the number of coins of each type was the same, we had taken x as the number of coins. But here, the number of coins itself has changed. So here, the solution will be slightly different. Let's say that the number of coins are 1x, 3x, 5x, 7x. Now 1x was the coin of 1 rupee, 3x was the number of coins of 50 paisa. I have written 0.5 because we are going to make the equation in rupee terms. 5x number of coins of 25 paise, 0.25, and 7x number of coins of 10 paise, 0.10. So now our equation can be made easily. 1 into 1x plus 0.5 into 3x plus 0.25 into 5x plus 0.10 into 7x. This represents the individual values of these sets of coins. 1 into 1x, value of 1 rupee coins. 0.5 into 3x, value of 50 paise coins. 0.25 into 5x, value of 25 paise coins. And 0.10 into 7x, value of the 10 paise coins. But all of this should add up to the total money in the bag, which is given to be 22.25. I hope this is very clear. If you solve this, it gives you. So the left hand side becomes 4.45x, which is equal to 22.25. And so x will be 5. Now what is the question? The question was, find the number of coins of each kind. That is the question. Now once we know that x is 5, all we have to do is to put this value here and get all the answers. So the number of coins of 1 rupee denomination will be 1x, which will be 5. 50 paise denomination will be 3x, 5 into 3 is 15. 25 paise denomination will be 5x, 5 into 5 is 25. And 10 paise denomination will be 7x. So that will be 7 into 5, which will be 35. So 5, 15, 25 and 35 are the 4 answers that we wanted. Question 19 has been solved. Let's move on. Example 20 says, given A is to B is 4 is to 5, B is to C is 20 is to 11, and C is to D is 6 is to 7. Find the value of A is to B is to C is to D. So what trick will we use here? What method will we use here? Very simple. Make the common term equal. So between A is to B and B is to C, we'll have to make B common, that is 5 and 20 common. Between B is to C and C is to D, we'll have to make C common, which is 11 and 6. And finally, we'll have to make the whole thing in a common ratio. So let's get started. Solution to example 20. So let us proceed step by step. A by B is 4 by 5 and B by C is 20 by 11. So we know very well that as the first step, we need to make 5 and 20 common. We can do that by taking the LCM of 20. And so that means I need to multiply the first one by 4 and the second one by 1. So this will give me 16 by 20 and this will give me 20 by 11. And so from here, the common ratio comes out to be 16 is to 20 is to 11, which is A is to B is to C. I hope all of you are able to see it. So we take it to the next level now. We know that C by D is equal to 6 by 7. So that means that from this 11 and from this 6, we have to come to a common number, and that common number has to be 66. So that can be obtained by multiplying the first ratio throughout by the first ratio is ABC, which is 16 is to 20 is to 11. Throughout we'll have to multiply it by 6. And the second was C is to D, which was 6 by 7. We'll have to multiply it throughout by 11. So the first one will give us 16 into 6, which will be 96. 20 into 6, 120, and 11 into 6, 66. And in the second case, we will have 66 is to 77. Now we know, do not be too scared by these horrifying looking numbers. It's actually pretty simple, that we have been able to make these two equal. So the question is solved. If these two are equal, then our final answer is absolutely apparent. A is to B is to C is to D will be nothing but 96 is to 120 is to 66 is to 77. Now you may very well ask that, sir, can we not simplify this any further? And the answer to that is no, you cannot. This is the best integral expression for the continuous ratio A is to B is to C is to D. 96 is to 120 is to 66 is to 77. This is to sign here is looking like 1. So let me rewrite it so that it becomes clear and there is no doubt at all. Try to simplify it further. There is no integral simplification of this anymore. I hope example 20 gave you a very good idea of how to work with continuous fractions like these. Okay, now we will take a quick look at the theory of proportions, which is nothing but an extension of the theory of ratios. Proportions. As you can see in the notepad, a statement expressing the equality of two ratios is called a proportion. So, if A is to B is equal to C is to D, or A by B is equal to C by D, then A, B, C, D are said to be in proportion. So, we have just seen that A is to B is equal to C is to D means A, B, C, D are in proportion. Here in this proportion, A is called the extreme just like D is also called the extreme. B and C are called the means. So, A and D are called extremes, B and C are called means, and A is also called the first proportional, B is also called the second proportional, C is called the third proportional, and D is called the fourth proportional. Another simple relationship is that the product of extremes A into D will be equal to the product of the means. So this is product of extremes. So the product of extremes, which is A and D, will be equal to the product of means, which is B into C. I hope that these basic definitions are very clear. Three or more quantities are said to be in continued proportion when A is to B is equal to B is to C is equal to C is to D, etc. Thus, A by B is equal to B by C, and if there is a continued proportion ahead, is equal to C by D is equal to etc. 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 So this is the definition of continued proportion. Now let us see some more interesting rules of proportion. If A is to B is equal to C is to D, then AD is equal to BC. This is called product of extremes is equal to product of means. Second, B by A will be D by C. This is called the invertendo law. Then A by C is equal to B by D. This is alternando. A plus B upon B will be C plus D upon D. This is called componendo. A minus B upon B will be C minus D upon D is called dividendo. And if we divide componendo by dividendo, we get componendo and dividendo. These are some simple results or laws of proportion that we should remember, because these laws of proportion can help us solve various tricky questions. So please go through it once again and memorize them. So once these laws of proportion are clear, before I take a couple of examples on these, let me just remind you of one more thing in continued proportion. If you see in the notepad, if we have A is to B is equal to B is to C, then it is obvious that A by B will be equal to B by C, which will give us B square is equal to AC. So in continuous proportion or continued proportion, B square is equal to AC, which means that B is called the mean in this continued proportion. So this is the mean proportional. Just remember this, and B square is equal to AC. A is the first proportion, C is the third proportional, and B is the mean proportional. I hope that is clear. Let us take up two examples now. Okay, example 20. Find the fourth proportional to 12a square, 9a square b and 6ab square. So here is the solution to example 20. Let us say that x is the fourth proportional. So if x is the fourth proportional, this will imply that 12a square upon 9a square b will be equal to 6ab square upon x. Remember a, b, c, d, the four proportionals. So a by b is equal to c by d, Exactly by the same logic, 12a square upon 9a square b will be 6ab square upon x. So all you have to do is take x to the LHS, multiply and simplify everything, and your final answer will be 9 by 2 ab cube. And so this is your fourth proportional to the series of these three proportionals. So x is equal to 9 by 2 ab cube is the answer. Let's move on to example 21. Okay, example 21 says, find the mean proportional between 9a square b and 25b cube. Here is the solution. Let us say that x is the mean proportional. So we are defining x as the mean proportional. So we know very well that if x is the mean proportional, then 9a square b upon x will be equal to x upon 25b cube. This is by basic definition. I will remind you of the definition of mean proportional. In fact, let me take you to that particular page. Here it is. In continued proportion, I hope you recall this discussion we had, that if a, b, c are in continued proportion, then a by b is equal to b by c, or b square is equal to ac, and b was the mean proportional. So using that, we have made this simple equation here. So you solve for x, and it gives you x square will be 9a square b into 25b cube. Now if you further simplify this, this gives you 225 into a square b fourth. So x will be nothing but plus minus 15 ab square. Please remember that when you take the square root of 225, it will be plus minus 15, and hence our final answer is plus minus 15 ab square. I hope this simple example is very clear to everyone. And let us take up a last question in proportions. Example 22. The question reads, if a upon b is equal to b upon c, then prove that a cube plus b cube upon b cube plus c cube is equal to ab upon c square. Let us solve this question. Solution to example 22. So this question can be solved in two ways. One, using the standard methods of componendo, alternando, etc. And second, using substitution method. We will solve it using both the methods. The first method here and the second method here. Okay, so let's solve it using both the methods. First, now it's given to us that a by b is equal to b by c, which implies b square is equal to ac. So that's the first thing we know. And we know that because a by b is equal to b by c, so this automatically implies that a cube upon b cube will be equal to b cube upon c cube. I hope this is clear. Just apply componendo. A cube plus b cube upon b cube will be b cube plus c cube upon c cube. This is componendo. Now apply alternando. Basically take this down here and take it up here. So a cube plus b cube upon b cube plus c cube, which is actually what is asked to us in the question. If you can see it now, that this is what is asked, will be equal to b cube upon c cube. This is nothing but alternando. Alternando is very simple. So now a cube plus b cube upon b cube plus c cube is nothing but b into b square upon c cube. But we know b square is equal to ac. So just put the value of b square is equal to ac in here And so you will now get B into AC upon C cube, which if you simplify gives you AB upon C square, which is what was asked. And thus we have been able to prove that A cube plus B cube upon B cube plus C cube is the same as AB upon C square, which is what was asked of us. Now the second method. The second method is very simple, which says let A by B is equal to B by C is equal to K. So that means A will be BK and B will be CK. So that means A will be, substitute the value of B here, CK into K, which will be CK square. And so you get A is equal to BK, which is CK square, and B is equal to CK. Now let us solve it further. Left hand side, A cube plus B cube upon B cube plus C cube. Let us put all the values in terms of any one common factor. I choose that to be C. So A is CK square. So this will be CK square whole cube plus B square, which is CK cube. The logic here is we are substituting everything in terms of one variable only, which in this case for C. You could do it in terms of A, you could do it in terms of B. Divided by B cube, which is CK whole cube plus C cube. So if you simplify this further, the RHS becomes C cube K to the power 6. Don't be scared, don't be scared, we'll solve it. Plus C cube K cube upon C cube K cube plus C cube. Take C cube K cube common, you will be left with K cube plus 1 upon C cube K cube 1 plus C square. Or rather, here take C cube common. So let me change the denominator here, so we can then cancel it out easily. So the denominator here now becomes, I take C cube common, so I have K cube plus 1. I hope that's clear. So what happens now? K cube plus 1 and K cube plus 1 get cancelled out. And if these two get cancelled out, finally C cube and C cube will also get cancelled out. And so what are you left with here? You are only left with K cube. This K cube now we have to prove is equal to AB upon C square. Can we prove that? Yes, we can prove that very easily. How? We know that A is CK square and B is CK divided by C square, which is nothing but K cube. Hence, LHS is equal to RHS. So revise this question carefully and see both the methods. I have explained both so that there can be no doubt left after this. Okay, now let us take a look at the concept of partnerships. Since this topic is directly related to ratio proportion, we have taken it along. Let us assume that three partners A, B and C decide to enter into a partnership together to do a certain business. And in order to do this business, they bring in their own capital. Let us say that A brings in rupees X, B brings in rupees Y, and C brings in rupees Z to run the business. At the end of the year or at the end of the accounting period, let us say that the total profit worth rupees P. How exactly should the profit be divided? So common sense tells us that the ratio of profits must be equal to the ratio of investments made by the partners. Thus, at the end of the year, profit for A is to profit for B is to profit for C will be equal to the ratios of investment of A is to investment of B is to investments of C, which in this case is given to us as X is to Y is to Z. But remember, not all businesses can make profits. So suppose the business ran into a loss, let us call it L. In that case, the ratio of the losses will also be the same. So practically, the one who invested more took a greater risk and the one who invested less took a lesser risk. I hope that this basic concept of sharing of profits or losses is absolutely clear. However, a small change. Let us say that the three partners brought in rupees X, Y and Z, but not for the same time period. So far in our discussion, we had assumed that the time period of the capital investment in the business was the same for all the partners. However, this may not be the case always. In all our calculations so far, we had assumed that the time for which the three partners had put in the capital in the business was the same. However, if the time period is not the same, then how shall our calculations change? Let us see. Let us say that partner A brought in rupees X for a time period of T1 months. Partner B brought in an investment of Y for a time period of T2 months. The time periods can be in days, months, years. They just have to be same for all the three. The units have to be same for all the three partners. And partner C brought in rupees Z for a time period of T3 months. Now obviously, things will change. How will things change? Let's take a simple look. Very, very simple. Now what will happen is, we have to talk about equivalent or rather, delete karo. Now obviously things will change. How? We have to now talk about effective investments. So what will effective investments be? For A, X rupees was put in for T1 months, so his effective investment was X into T1. For B, it will become Y into T2. And for C, it will become Z into T3. Thus, the ratio of profits and hence loss will be equal to the ratio of effective investments. So, profit of A is to profit of B is to profit of C will be X T1 is to Y T2 is to Z T3. I hope that this logic is very clear to everyone. So we have seen the basic working in partnerships. Let us now try to solve two questions which illustrate this working. Okay, here is example 23. In a business, A, B and C invested rupees 380, rupees 400 and rupees 420 respectively. Divide a net profit of rupees 180 among them. Here is the solution. We know that the ratio of profits will always be equal to the ratio of investments made by the partners, as we can see in the notepad. So the ratio of profits for A is to profit for B is to profit for C will be the ratio of their investments, which will be 380 is to 400 is to 420, which can be further simplified and written as 19 is to 20 is to 21. Just divide by 20 throughout and you will get 19 is to 20 is to 21 as the simplest integral expression of this ratio. So, and we know that the total profit was rupees 180. This is given to us in the question. So the profit of A obviously will be 19 upon 19 plus 20 plus 21 into 180 rupees, which will be 57 rupees. Similarly, the profit of B will be 20 upon 60 into 180. 60 is the sum of 19 plus 20 plus 21 into 180, which will actually be rupees 60. And similarly, the profit of C will be 21 upon 60 into 180, which will be rupees 63. This is how this simple question can be solved. So our final answer, the profits are 57, 60 and 63 rupees respectively, which will be the ratio 19 is to 20 is to 21, which is fairly obvious. We take up the last example now, example 24. Okay, let us read the question. Larry, Sergey and Eric entered in a partnership. Larry put in $320 for 4 months. Sergey put in $510 for 3 months and Eric put in $270 for 5 months. If the total profit was $208, then find the profit share of these partners. A very simple question, and here is the solution to the same. We know very well that effective investment concept has to be used now. So the effective investments for the 3 partners, Larry, Sergey and Eric, will be 320. Let me write it properly. 320. 320 into 4 is to 510 into 3 is to 270 into 5, which if further simplified gives us 1280 is to 1530 is to 1350, which gives us 128 is to 153 is to 135. Therefore, the profit of Larry would be 128 upon 128 plus 153 plus 135 into the total profit, which is given to us as $208. 208. And so the profit share of Larry will be $64. By the same logic, the profit share of Sergey will be 153 upon 128 plus 153 plus 135 into $208, which will be $76.5. And the final answers, the 3 profits come out to be, the profit for Sergey comes out to be $76.5 and the profit for Eric comes out to be $67.5. Thus, the answers are $64, $76.5 and $67.5. We hope that these 2 examples have made the basic working on partnerships absolutely clear to you. Now let us take up a quick revision exercise. I call it quick questions. Take a look in the notepad. Here are 10 questions for you, and we want to solve them really fast. So let's get cracking, and ideally we should be able to solve all of them mentally. Here, for illustration purposes, I will write and solve them one by one. Let us get started. Question number 1. Find A is to B is to C if 6A is equal to 9B is equal to 10C. Now, this can be solved very easily because we know that if 6A is equal to 9B is equal to 10C, then this implies that A upon 1 by 6 is equal to B upon 1 by 9 is equal to C upon 1 by 10, which further implies that A is to B is to C are in the ratio 1 by 6 is to 1 by 9 is to 1 by 10. So, the ratio of A is to B is to C has been found. 1 by 6 is to 1 by 9 is to 1 by 10. That's our answer. But we wouldn't want an answer in such a fraction shape. So take the LCM of 6, 9 and 10, and that will give you 90 as the LCM. So what will be left in the numerator then? With 6, it will give you 15. With 9, it will give you 10. And with 10, it will give you 9. And so our final answer is 15 is to 10 is to 9 is the final answer. I hope this is clear. We move on to question number 2. The ratio of boys to girls in a school is 5 is to 2. Find the difference between their numbers. Now, I missed out on a small data. I will add that right now. In a school of 1750. Absolutely right. We have added that. Now the question is complete. Let's solve it. So the ratio of boys to girls in a school of 1750 is 5 is to 2. Find the difference between their numbers. Now it is very obvious that 5 minus 2 is equal to 3. 5 parts and 2 parts. So the total would have been 7 parts of 1750. So the difference will be 5 minus 2 is 3. 3 parts of 1750. 3 parts out of how many parts? 7 parts. So our final answer will be 3 by 7 of 1750. Now if you solve this, 3 by 7 of 1750 will directly give you 750 as the answer. How? Just solve this. This will give you 250 and 250 into 3 is 750. 750 is our answer. Question number 3. If A is to B is equal to 3 is to 4, what is 2A minus B is to 3A minus 2B? Simple. Use the substitution method. Let A is equal to 3K and B will be what? 4K. Just put these values in this expression. 2A minus B upon 3A minus 2B. So you will have 2 into 3K, 6K minus 4K upon 3A, 3 into 3K, 9K minus 2B, 8K. So that will give you 2K upon K, which will be 2, is our final answer. So our final answer here is 2 for question number 3. We come to question number 4. Find the mean proportional to 4 and 9. Very simple. 4 by x will be x by 9, which will give you x square is equal to 36, which gives you x is equal to 6. So the mean proportional in question number 4 to 4 and 9 will be 6. We have just proven it. We come to question number 5. Two numbers are in a ratio 3 is to 7 and the difference is 24. Find the numbers. Once again, very simple. If 3x and 7x are the numbers, then 4x is given to be 24. So that gives me x is equal to 6. But I have to find the numbers, and the numbers were 3x and 7x. So put x here. So 3x will be 18 and 7x will be 42. This is our answer for question number 5. I hope this is absolutely clear. We come to question number 6. What is the third proportional to 3 and 6? Question number 6. So question 6, the solution is very simple. you will have the third proportional to 3 by 6 will be found by 3 by 6 will be equal to 6 by x. That gives you x will be equal to 36 by 3, which will be 12. So our answer to question number 6 is 12. I hope this is clear. We move on to question number 7. If A is to B is 3 is to 8 and B is to C is 5 is to 6, then A is to B is to C is how much? You know we have to make the common term common. B is 8 and B is 5. So it is obvious that we need to make 8 and 5 common. Take the LCM of 8 and 5. What will be the LCM of 8 and 5? It will be 40. So the first expression 3 is to 8 needs to be multiplied throughout by 5. So this will become 15 is to 40. And the second expression 5 is to 6 needs to be multiplied throughout by 8. So this will become 40 is to 48. And so our final answer will be 15 is to 40 is to 48 for question number 7. I hope this is very clear. 15 is to 40 is to 48, and we should be able to do it mentally with some practice. Question number 8. The simplest ratio of 24 is to 30. I am sure you will be able to see that the answer has to be 4 by 5. You cannot simplify it any further. Question number 9. The fourth proportional to 2, 6 and 8 is 2 by 6 is equal to 8 by x, which will give you x to be 8 into 6 by 2. And as you can very well see that in this case for question number 9, the answer will be 24. I hope this is clear. And the last one, which is greater, 2 by 5 or 3 by 7? Now we know that we need to make the LCM common here, 5 and 7. So for 5 and 7, the LCM here will be 35. So just multiply 2 by 5 throughout by 7 and multiply 3 by 7 by 5 by 5. So this becomes 14 by 35 and this becomes 15 by 35. It is very obvious that 15 is more than 14 and hence 3 by 7 is our final answer. I hope that this exercise gave you a very good hint as to how such questions can be done fast and mentally. Take a quick look once again in the notepad. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 questions done rapidly for you using basic concepts. All of you are capable of doing it. Have faith in your capabilities. Practice as much as you can, because practice will truly make you perfect. We move on, and now we will take up 6 final questions and then the session would be concluded. Okay, here is our first question. We are now concluding the session with these beautiful questions, the final set of questions. What least number should be subtracted from each of the numbers 12, 17, 22 and 32 so that the remainders may be in proportion? Solution. The least number be x. So this means that 12 minus x, 17 minus x, 22 minus x and 32 minus x will be in proportion. So the equation now will be 12 minus x upon 17 minus x will be 22 minus x upon 32 minus x. And if this is the equation, this can be solved to get the value of x. I hope this method is very clear. And if you solve it, the value of x which you will get will be equal to 2. But as you can understand that in this method, a quadratic equation will be formed. And so it will take a few seconds more. Can we have a very fast shortcut method? Yes, a faster shortcut method is indeed available. Start from the options. Look at option number 1. What is option number 1? 2. If option 1 is correct, then 2 is the answer. So that means just substitute this value of 2 everywhere in x here. 12 minus 2, 10, 17 minus 2, 15, 22 minus 2, 20, 32 minus 2, 30. So that means 10, 15, 20 and 30 should be in proportion. 10 by 15 should be equal to 20 by 30 if option 1 is correct, which is 1 by 3, or rather 2 by 3 is equal to 2 by 3. Hence, this is the correct answer. We were very lucky option 1 itself came out to be true. Hence, option 1, which is 2, is the correct answer. That is, 2 is the smallest number to be subtracted to make them in proportion. Now, if you are unlucky, option 4 will be correct. So, in that case, you will need to check option 1, option 2 and option 3 only, not the option 4, because if the first 3 options are wrong, you need to automatically mark option 4. I hope this question is understood. We move on to the second. The question reads, the monthly incomes of 2 persons are in the ratio of 4:5 and the monthly expenditures are in the ratio 7:9. If each saves rupees 50 a month, then what are their monthly incomes? Here is the solution. Let us say the monthly incomes are 4x and 5x, and let us say the monthly expenditures are 7y and 9y. Remember, if income is taken in x, expenditure has to be taken in a different variable y, because ratios can never be of 2 different things. So income is a different thing, expenditure is a different thing, and as per our basic definition of ratio, for different things you cannot have a common ratio. Hence x and y are separate. So what equations do we get? From here you get the first equation, 4x minus 7y, and from here you get the second one, 5x minus 9y, income minus expenditure, and each is saving 50 rupees a month. We know very well that income minus expenditure is equal to saving, and each is saving 50 rupees a month. So the 2 equations are now ready with us. What are the 2 equations? See the notepad carefully. 4x minus 7y is equal to 50 and 5x minus 9y is equal to 50. The moment you solve it, you get x equal to 100, and from there you can get the incomes as 400 and 500. So option number 4 is correct. This is the regular method. So this is the regular method, but it takes time. So do we have a shortcut method? Yes, we have this habit of always finding a shortcut, because in objective competitive tests, it's a good idea to work with shortcuts, provided your conceptual clarity is clear or is good. Shortcut method. Start from the options. The monthly incomes are 4:5 and expenses are 7:9. If each says 50, then what are their monthly incomes? Start with option number 1, 100 and 125. Each is saving 50 rupees a month and the incomes are 100 and 125. So if the incomes are 100 and 125 and we are saving 50, so what are our expenses? 50 and 75. You don't even need to do all this. Just see that the monthly income should be in the ratio 4:5 first. Option 1, are the monthly income in the ratio 4:5? Yes, so option 1 may be right. Option 2, are the ratio 4:5? Yes, so option 2 may be right. Option 3, are the incomes in the ratio 4:5? Yes, so option 3 may also be right. And option 4, are the 2 in the ratio 4:5? Yes, so again option 4 may be right. So this trick did not help us eliminate any option. So we will have to really work from the saving. I'm trying to explain how shortcut methods can have various colors. So if the savings are 50, we saw that the expenses in the first option were 50 and 75. Is this in the ratio 7:9? No. So option 1 is actually wrong. Option 2, 200 and 250. Subtract 50 from each. What do you get? 150. If you subtract 50, you get 150, and from 250 it gets 200. So this is 3:4, which is not 7:9. So option 2 is wrong. Option 3 says 300 and 375. Subtract 50, so you get 250 and 325. This is definitely not a ratio 7:9. So option 3 is wrong. Option 4 says 400 and 500. Subtract 50, you get 350 and 450, which gives you a ratio 7:9. Hence, option 4 is indeed correct. This is how a shortcut method can be used. Please remember, shortcut methods require brains. This was a direct example of that. We move on to the next question. Okay, the question is, rupees 375 is divided among A, B and C, so that if rupees 4, 5 and 6 be subtracted from the respective shares, the remainders will be in the ratio 3:4:5. Then their shares in rupees are respectively option 1, 2, 3, 4. Here is the solution to this very simple question. Rupees 375 is divided among A, B and C, so that if 4, 5 and 6 be subtracted, 4 plus 5 plus 6 is 15. So in all, rupees 15 was subtracted. Now rupees 15 was subtracted from what? From 375. So 375 minus 15. So you are actually left out with 360. And out of this 360, he says that the remainders, so the remainders will be from 360, were in the ratio 3:4:5. So all you have to do is make a simple equation. 3x plus 4x plus 5x is equal to 360, which gives you 12x is equal to 360, which gives you x is equal to 30, which gives you their subtracted shares or reduced shares as 30 into 3, 90, 4 into 30 or 30 into 4, 120, and 30 into 5, 150. But these were the subtracted shares because 4, 5, 6 was reduced. So 90 plus 4, 120 plus 5, and 150 plus 6 should be the final shares. Let us see the options. Do we have any option like this? 94. Yes, we have option 3. Option 3 has to be correct. 94, 125, 156. That is the answer. Option number 3. I hope this solution was clear. But once again, we have this habit of trying to find a shortcut. Let's see if a shortcut method exists for this question also. Let's try and see. 375, you subtract 4, 5, 6, and the remainders are in the ratio 3:4:5. Then what are their original shares? Now look at the 4 options. Look at the options. Look at option number 1. Option 1 says 175, 125, 75. Now this option is patently wrong because this cannot be in the ratio 3:4:5. This is the reducing ratio, whereas we are being asked an increasing ratio. So option 1 is directly ruled out. Option 2, 120, 125, 130. If you look at this, some reflection, some practice, some experience will tell you that such numbers cannot come in the ratio 3:4:5 because the first number 120 is a pretty large number. So this is wrong. Third, 94, 125, 156. Now I don't know that this is actually the right answer. How do I work with this? 3:4:5. Yes, this can be in a ratio 3:4:5. Maybe. At least we cannot directly rule it out. Now let me reduce 4, 5 and 6 from these. Minus 4, minus 5, minus 6. So what do I get? 90, 120, 150. This should be in the ratio 3:4:5, which is actually 3:4:5. And so option 3 is correct. I do not need to check option number 4. So if you have some experience and practice and brains, then you could have solved this question working backward from option in less than 30 seconds. We move on to the next question. The question is, 4 years ago, the ratio of ages of A and B was 13:9, and 8 years hence, the ratio will be 4:3. Here is the solution. Let the present ages of A and B B, A and B itself. So what will be the equations now? A minus 4 was the age 4 years ago and B minus 4 was the age 4 years ago. The ratio was 13:9. This is the first equation. And 8 years hence, A plus 8 upon B plus 8 will be 4:3. This will be our second equation. So you look at both the equations in the notepad carefully. So you have A minus 4 upon B minus 4 is 13:9, 4 years ago ages ratio, and A plus 8 upon B plus 8 is 4:3, the ratio 8 years hence. Thus, you can solve these two equations, and once you solve this, you will get A is equal to 56 and B is equal to 40. You'll have to solve these two by cross multiplying and all individually, and then you subtract and solve, and so the difference will be 16 years, which is option number 3. Now the next question. In a 40 liters mixture of milk and water, the ratio of milk and water is 3:1. How much water be added to the mixture so that the ratio of milk and water becomes 1:3? Here is the solution. Initially, we have a 40 liter mixture of milk and water, and the ratio of milk and water, milk is to water, is 3:1. So out of 40, it is obvious that milk will be 30 liters and water will be 10 liters, because 30 plus 10 is equal to 40. How much water should be added to the mixture? So we are asked, let us say X liter of water. So the new water will become 10 plus X total water, so that the ratio of milk and water becomes 1:3. Milk remains 30, water becomes 10 plus X, and we are now given that 30 divided by 10 plus X should be 1/3. So if you solve this, this gives you that X is 80. So if X is 80 is correct, we should be able to prove it right now. So if 80 liter of water is added, new water will become 90. Old milk was 30, so 30:90 will be 1:3, and the ratio is precisely 1:3, which is wanted. Hence the answer is 80, which is option number 1. This is the correct answer. Now in this particular question, can we have a shortcut? Yes, we can. See, option number 1 says 80 liters. So 80 liter is added to how much? Initial water was 10 liters. So 80 plus 10, 90, and original was 30. So 30, 90, 1:3, hence solved. So a shortcut is indeed possible. But if you look at it carefully, the shortcut method actually used the same concept. We were very lucky that option 1 itself came out to be correct. So this is the shortcut for this question. Here is the last question for this session. Volumes proportional to 3, 4 and 7 of 3 different substances are mixed together. The weights of equal volumes of the substances are in the ratio 5:2:6. The weight of the third substance contained in 130 kg of the mixture is. Okay, so here is the solution. Volumes given to us are in the ratio 3, 4 and 7. Densities are given to us in the ratio 5:6, because it says weights of equal volume. So that is density 5:6. And now he is finally asking us the weight of the third substance. Recall the original formula. We know that density is equal to weight upon volume. And so weight will be density into volume. I hope this basic physics is clear in your head. So volume 3, 4, 7. How much is the total? 3 plus 4, 7 plus 7, 14. So the volumes are in the ratio 3/14 is to 4/14 is to 7/14. Densities 5 plus 2, 7 plus 6, 13. So the densities are in the ratio 5:13 is to 2:13 is to 6:13. And now we are asked to find weight. But we know the formula for weight is density into volume. because from the basic physics, so just multiply it together, and if you multiply it together, so the ratio of these three weights will be 3 by 14 into 5 by 13 is to 4 by 14 into 2 by 13 is to 7 by 14 into 6 by 13. And so if you solve this, this comes out to 16, or rather 15, 8 and 42. You will have to do some solving here, and you will finally get the ratios of weights as 15, 8, 42. If you add 15, 8 and 42, that will come out to 65. So actually the weights are in the ratio 15 by 65 is to 8 by 65 is to 42 by 65. But look at the question. The total weight of the mixture is 130 kgs. So I hope now we can solve for anything. We are asked to find the weight of the third substance, that is this. So 42 by 65 into 130 has to be our final answer, and if you solve it, it will come out to be 84 kgs, which is option number 3. So this was a rather different kind of a question, but a useful one, and this is how you have to solve it. With this, my dear student, we come to the end of the session on ratio, proportion and partnerships. I hope you enjoyed the session. Keep a positive spirit, revise the entire session carefully, and you will surely do very well for yourself.